Hello folks, and welcome to this pretty simple and to the point PostgreSQL long course. So without wasting any single unit, let's get straight to it. So the first question arises, what is PostgreSQL? PostgreSQL is a top open source database management software system. It is fast, trustworthy, adaptable, easy to use, and has advanced features that allows complicated applications to be built in an error-tolerable workspace. There are two different packages of PostgreSQL, each for specific purpose. PostgreSQL client package, which works on the client side to connect to servers, while the PostgreSQL server package allows your system to set up and host your own databases. It focuses on extensibility and compliance with the standards defined for the object relational database management systems. It emphasizes mainly on transactional, updatable, and materialized views, foreign keys, and triggers. It focuses on supporting stored procedural data and related functions. Alright, the PostgreSQL has gained a very strong reputation in terms of trustworthiness, robustness, recognized architecture, and a strong open source community that works day and night to deliver the best solution for all the database related problems. PostgreSQL is available on most of the operating systems including Linux, Windows, Mac, BSD, and many more. Alright, we have learned enough about PostgreSQL. Now let's see how is it different from other database management systems like MySQL and MongoDB. When managing relational databases, people refer open source relational databases. PostgreSQL, MySQL, and MongoDB are major relational database management systems, providing quick and reliable solutions competing with SQL servers. PostgreSQL has a lot of advanced features and it is usually defined as the open source version of Oracle DB. While MySQL is famous for its speed and easy to use interface, and MongoDB is famous for storing data in the form of flexible documents like JSON rather than the usual table style method found in SQL databases. Now, the main modules used while working with PostgreSQL are triggers, roles, tables, stored procedural data, constraints on data, and views. Each table is composed of rows and columns, and each row is used as a primary key by PostgreSQL and uses foreign keys for ensuring the referenced integrity between two related tables. PostgreSQL supports all the NoSQL feature, and that's why it is famous for working with NoSQL databases. While MySQL works just like PostgreSQL, but it only uses tables as the main modules and has fewer features than PostgreSQL. While the new MySQL version supports the NoSQL feature, but it still doesn't have an advanced feature set as found in PostgreSQL. On the other side, MongoDB uses indexes as the main component while searching for a document. If an index is missing, then the whole collection is searched to find the target documents in the query. This can slow the read time of database. Now if we look at the syntax of the PostgreSQL and MySQL, the syntax of PostgreSQL and MySQL is the same, like select static from customer. But if we want to do the same thing in MongoDB, the syntax is db.customer.find parentheses. Alright, we have compared enough PostgreSQL with some other database management system. Let's move towards installation process. First of all, update and upgrade your apt package repository. Now upgrade it. Now install the client package. Now install the PostgreSQL server. Alright, PostgreSQL client package and PostgreSQL server is installed. Now let me clear the terminal. And now we can check if it is available on the listing ports using this command. By the way, you can enable or disable the startup option for booting up the system using the systemctl command. And if you want to disable it, you just need to write disable instead of enable. Alright, I hope you got it. And you should also update the firewall setting for PostgreSQL so that the system can receive PostgreSQL connection via 5432 port using this command. Alright, PostgreSQL is installed. Now we'll have to connect to the PostgreSQL environment as a super user in order to perform commands on the database. So run this command. Now that we have installed PostgreSQL Ubuntu, let me clear the terminal. We should know a few data definition DDL commands. The first command is create. It creates a new object such as database, table, schema or function. The next command is alter. It changes and modifies the current element in the database. Another command is drop, which deletes the current objects or elements in the database. And another command is truncate. It deletes the data present inside the table without deleting the whole table. And another command is rename, which is used to rename any object in combination with the alter table command. Alright, done with the data types. Now let's take a look at some types of keys in the PostgreSQL. There are total 5 keys. Candidate key, which is combination of a small set of attributes to find a set of unique tuples. Super key, which is a set of attributes to find a tuple. And a primary key, which is a set of attributes that have unique identification of tuples. Alternate key, except the primary key, other candidate keys are called alternate keys. And the last foreign key, it takes attribute from another key as a reference. Alright, there are a few constraints that can be implemented in database like not null, unique, check, default and index. Now not null, it applies a constraint that no null value is stored in a column. And unique, it applies a constraint that uniquely defines all the values. The check, it is utilized in order to check for a condition in a column. And default, it applies all the values which are present in the system when no new value is specified for the column. And the last index, it is applied to create and obtain data from a database in a fast way. Alright, now let's move towards data manipulation or DML keywords. It contains all the commands which can manipulate data in the database system. The first one is set search path. It is used to identify which of the schemas should be implemented for operating. Insert, which is used to insert new data into a table in the database system. And update, which is implemented to modify the current state of the table. And delete, which is applied to delete the current objects in a table. And the last is select, which is implemented to select data from a table and display them on the screen as an output. Alright, now let's take a look at logical operators in PostgreSQL. The AND, OR, NOT are the 3 logical operators used in PostgreSQL. AND operator is used to display results which satisfy all the conditions defined in the select statement. OR operator is used to display a result which satisfied one of the conditions defined in the select statement. And NOT operator is used to display results if all conditions in the statement are not defined in the select statement. And now at the last, aggregate functions. Most of the common aggregate functions are sum, average, count, minimum and maximum. Alright, now that we have all the theoretical knowledge, it's time to get back to some practical stuff. Now I'll show you how to create a database in PostgreSQL and I'll make an example database with the name test1, which will have the default value that any database can have. So the general syntax for creating a database is create database and database name. Alright. Semicolon. Test1 database is created. Now if you want to list out the new database created, there are actually several methods to list down the databases. Run the \list command. Oops, sorry for that. List. Alright, and to list out all the database and templates, run the \l command. There is a more advanced command for listing out specific databases from a list which displays the disk size of each of the database, which is \list plus. You can do the same thing using this command. Alright, there is actually another command for listing databases. It uses certain advanced condition queries like select dat name from pg_database where dat is template is equal to false. This command will display only the names of databases note the overall structure and description and exclude templates. If no database are present, it will display error on the screen. Alright, now if you want to connect to this database, run \c space test1. Alright, now let me clear the terminal and get back to the Postgres database. Alright, now if you want to delete the database for some reason, run the command drop database name. Alright, now in case if our database is in use by accounts and active, then drop database command cannot delete it, as you can see. For this purpose, you'll have to disable the database first and then delete it using the pg_state_activity phrase. This can be performed by executing the command Alright, this command has disabled the test1 database and now you can terminate it by using the command This PSQL command enables you to delete the test1 database from the system. Now delete the database. It got deleted. Now if I list down the table, it isn't here anymore. That's great. Let me clear the terminal. Alright, now you may face errors in database. So I have compiled a list of errors that can be avoided if the methods are properly performed. Like the first error could be create DB command not found. This error arises due to the failed installation of PostgreSQL database. You have to execute the create DB command from the PostgreSQL installation folder. Second error could be no such file running in the PostgreSQL server. This error occurs if the PostgreSQL is not started properly. The third error could be fatal role user account doesn't exist. It occurs if a user account is not created in PostgreSQL and still used here. And fourth error could be permission denied. This error will occur if the PostgreSQL user account doesn't have access to the permissions for creating a database. For this purpose, you'll have to assign permissions to the user account in order to let it access the create command. Alright, done with the database creation, listing and deletion. Now let's talk about tables. First, how to create tables in PostgreSQL. I'll make a table with the name pk_items that will show all the components of a toolbox item. So in order to create a table, execute the command A new table is created. Now you can check the new table by typing the command \t. It has displayed an output table, and if you want to list out all the tables present in the database, run the command \t. You can also check the contents of a table using the /t command with the name of the table. It will list out all the rows and columns in the bk_items table. Alright, after creating and showing the tables, let's see how can we insert data into the tables. Let me clear the terminal first. The general syntax of insert command is this. This general syntax has insert into keyword followed by a table name and other values for data to be entered, ended by semicolon. You can also add multiple columns with multiple values where each value is separated by a comma. Do you know that you can also insert data into tables that is present in another table by using this command? So first of all, create a new table with the name student using this command. Now to insert data into rows of the student table, run this command. Alright, the table was created successfully and data is inserted. Now if you want to insert character data, then they must be enclosed in a single code, while for numerical data you can just enter the number and separate them by a comma. Not null keyword is used if there is no value for the given column, then a default value is utilized. Alright, and now if you want to verify where the row is inserted or not, run the select command. Alright, that's great. Now you can insert multiple rows to the student table using one command. Let's try to do that. Alright, that's great. Two rows are added into the table student. Now let's see how can we add date in a table. In order to insert a date in student table, you have to add a new column to it by executing the command. Alright, the table is altered. The date format in PostgreSQL is year, month and date. Alright, now let's see another example to insert data. Alright, we have inserted another row into the table. Now you can also use a default keyword that will set each of the date column to a default value. Let's try that as well. Alright, we have inserted a lot of rows into the table. Now let's see the state of the table. Alright, as you can see, all the rows that I have added are inserted into the table. That's great. Let me clear the terminal. And now let's see another example in which we are gonna insert data from one table to another table. Alright, so first create a new table with the name as temp student and structure, just like the student table by executing the command. Alright, now list the table using the \t command. Okay, a new table temp student is created. Now insert rows from student table by using this command. Alright, now in order to verify this operation, execute the command to know whether the value of the student table are copied to the temp table or not. Oops, temp table is not a table, it's actually temp student. I'm sorry for that. Alright, that's great. Now let me clear the terminal. Now that we have learned about data insertion, now let's see how can we alter it. The table data can be changed using this command, alter table, table name and action to take. Now let's try that. This will add an extra column to the existing table. Now type \t space bk_items to check the table. You can see another column functioning is added. You can actually also add value that can use true or false value from Boolean function by executing the command. You can make sure that the boolean value is not null using this command. Alright, you can also rename this column using the command If you want to remove the column that we added to the bk_items tables, run this command. Well, you can actually rename the bk items to a whole new value by running the command. Alright, done with the alter commands. Now let's see how can we delete tables. Let me clear the terminal first. You can delete the tables that you created by using the command drop table bk_items. Okay, if a table is not found in the database, then the error table bk items doesn't exist will display on the prompt window, as you can see here. In order to delete a table without enabling this error, execute the command drop table if exists bk_items. It will delete the table if it exists and then return to the prompt window. Alright, since we have changed the name, that's why it says the table doesn't exist. Alright, now let's move to our next topic. Let me clear the terminal. Data types. There are basically supported data types which are demarcated while generating database tables. The different types in PostgreSQL data are Boolean, binary, monetary, enumerated, date, time, character, numeric, array, and JSON data types. In binary data types, the binary data types allows binary string storage in PostgreSQL, like and in monetary data types, it stores the current amount with a precision number which is fractionally fixed. And in enumerated data types, it includes a stationary ordered set of standards. This is far parallel to the enum data types that were helped in the encoding. In PostgreSQL, if enumerated data types are created once, it will further be used in any added data type. In datetime data type, it is given to the variable that is expected to store only the time value. An accurate layout of time is required such that it can be stored in this variable. Such data type is one of the most significant data types in PostgreSQL, as it is utilized to monitor all the associated communications. The available datetime data types are time, it only stores time and doesn't store date at all. Date, it is opposite to the time data type as it only stores date. Timestamp Z, it stores both the date and time also with the timestamp. While timestamp without Z, it stores both time and date but doesn't store timestamp. Alright? Another data type is interval. In such data type, the storage size is 12 bytes. It can store a particular time interval, for example 8 months ago, 5 years, 6 months, 11 days. Alright? Now let's look at an example. Alright, done with the date time. Now basically there are three major character data types: char data type, varchar data types, and text data type. Char data type, which is used where there is a need to store a single character value. In case of putting more than one character, it will show an error like A, B or S. Alright, while varchar data type with some numerical value, or we can say a number written along, which denotes that it will be only capable of holding or storing a specific number. Alright, like varchar 9 means it can only hold a maximum of 9 characters. And in text data type, it can store long string values, as one can use this data type for such text whose length is unknown. Alright, next, numeric data types. Numeric data types are further divided into two types: integer data type and floating point number. In integer data type, all the variables stored in this data type must have an integer value only. If the value is not an integer value, there would be an error. In PostgreSQL, there are further types as a small integer, integer, and big integer present having specific ranges. Let's look at the syntax. Alright, now let's move towards floating point number. Now floating point number itself has three different types based on size: float, numeric, and real. Float, which is floating point number precision, and numeric, which is number data type that includes the exact number, and real, a 4-byte decimal number. Let's look at an example as well. Alright, now there are also some other data types like array and JSON. Array can store a string or whole set of values. However, all the arrays must be of same kind of data type, otherwise an error would occur. And JSON data type is one of the most important data type, as it is capable of storing complex JSON data. Alright, now we are done with the data types. Now let's move to our next topic, that how can we add user accounts in PostgreSQL. Let me clear the terminal. When you install the PostgreSQL database system for the first time, it always includes a super user known as name Postgres. Sometimes you need to add more users to your database and you grant specific permission to them. So I'll show you how to add a new user account to the PostgreSQL database and how to grant privileges to various user accounts on PostgreSQL. So first of all, let's create a new user by name and has certain constraints, and the general syntax is this. The option can include many values. We'll see a couple of them. Now let's create a new user with the name John. Alright, and if you want to assign root or super user permission, you should use with super user. Alright, you can also create a user account and grant him root privileges for a given time period. Let's have a look at the command for that. Alright, now you will be able to check the new user in the user account list by executing \tu command. As you can see, the new user John is created with all the attributes defined in the create user command. Whenever create role command is used and login is not defined in the attributes, then by default the no login conditional statement attribute gets activated. Now you can add any user created to the database and grant sudo or super user privileges to it by using grant all privileges command. Let's look at that. Oops, database 1 doesn't exist. Let me create a database first. Now try to run the command again. Alright, now a user can access the database with all the privileges defined within that database. Alright, now you can also edit the current user's privileges to make it an ordinary user or a super user with alter user keyword. Now let's suppose you have assigned permissions to a different account and want to end these permissions, then no need to panic because you can always revoke these permissions. Now let's alter the John's privileges. Role altered. Well, you can check these change roles with the \du command. Alright, that's great. You can also grant permissions to the user John via the alter command like this. Alter user John with super user. Now let's see, when you no longer need a user in your database, you can delete him and it won't affect any of the database. The general syntax is drop user username. If there is no user account present with the name specified, or if the database objects are dependent on it, then it will display an error describing the role cannot be dropped. Let's try to drop user John. Alright, it shows an error that the John user account cannot be dropped because objects are dependent on it. You can change the owner by using the alter user command and then delete the above user by the drop user command. Alright, now let's see how to create a schema in PostgreSQL. I'll make two example schema with the name business and SCHM that will support the concept of creating schema. The command for creating schema in PostgreSQL is create schema. Alright, the general syntax for creating a new schema is this. In this command, create schema is a necessary keyword and schema name must be distinctive in the current working database. If not exist phrase is used as a conditional statement in case a schema doesn't exist. Alright, and if the schema exists with a name and the if not exist conditional phrase is not used, then it will result in an error. And if you want to create schema for a specific user, the general syntax is this. Let's take a look at some example. Now let's list out all the schemas in the database. And now let's create schema for a user account. First of all, create a new user account. First create database testdb. Now create user, let's say John X with encrypted password. Alright. Now grant all privileges on database testdb to John. Now create a new schema for the user account John. By the way, you can also use the conditional phrase if not exist before the keyword authorization if you want. Alright, now you can create a new schema with the name SCHM that will also create some objects associated with it. These objects include the new TB table and new TB underscore due underscore list view. Both of these are only associated with the SCHM schema. Alright. Alright, schema is created. Now you can use all the alter commands to modify the properties of the schema. The general syntax is this. Let's see an example. You can rename the SCHM schema to a new name through the alter schema command. Alright, this is all about schemas. Now let's see how can we create an index in PostgreSQL. What is index actually? An index is a method to retrieve some less number of rows from a table effectively. So the index is only useful when the required number of rows which are to be retrieved is quite small. Furthermore, there are also useful B-tree indexes used to avoid sorting. There are various types of indexes used in PostgreSQL and have distinct ways to use each type of index. So let's discuss various types of indexes and various methods to use them further. The most common index type is known as B-tree index. B-tree is one of the main types of indexes. It is the one we get by default whenever we create index. It is known that all databases have B-tree indexes. It tries to keep it balanced as the sum of data stored in each division of the index is approximately the same. This type of index is majorly used for equality and handle queries effectively. B-tree indexes can practically operate against every kind of data type and additionally can also be used to help in retrieving null values. These are designed in a way to work efficiently with caching, also in case of partially cached. Alright, the second type of index is hash index, and these indexes are specifically worked with in case of equivalent comparisons. But there is an issue that these indexes are not considered as transaction safe and they are not preferred. They need to be rebuilt once the index crashes and thus they are not replicated to the user. So as compared to B-tree, its advantages are rather less. In the case of PostgreSQL and above levels, these indexes are now noticed to be logged right ahead and further replicated to the user or followers. And another type is known as Generalized Inverted Index (GIN). These are useful in a situation when an index is operated to map different values to a single row. These are good for array indexing needs. Lastly, the type of index is Generalized Search Tree (GIST). This type allows us to make normally balanced tree structure. These are used for advanced operations which are beyond equality and various range comparisons. For full text search and geometric data type, the GIST index is used. Alright, now let's look at some commands. How can we easily create an index by create index statement? The general syntax is this. In this syntax, index name is the name to be assigned to the created index. The table name is the name of the table containing a new index and concurrently is used for the purpose that the table will not log when the index is created. Actually, there is by default function that the table is logged at the time when an index is created. And unique is also optional, and this modifier indicates the values that the combinations must be unique while being in the index column. And in next column 1, 2 and so on. This contains the column which is to be used in the index. ASC is optional that the index in the column is organized in ascending order, and DASC is optional that the index in the column is arranged in descending order. Well, let's try to create an index. Oops, order details table actually doesn't exist, so let me create table first. Oops, I forgot to give the table name. That's my mistake. Sorry for that. And the type is int. It's not ID. Alright. Now let's run the command again. Index is created. And for unique index, we need to make sure that we enter the unique keyword just before the index. Alright. And now for the purpose of dropping an index, the statement drop index is used. The general syntax is this. In this, restrict means if there are any objects that really depends on the index, then the restrict statement will prevent the index from dropping. And cascade means by using this, all the objects which are reliant on the current index will also drop. And if exists means this is an optional part. If this is specified, then even if the index doesn't exist, it won't show an error. And concurrently, also an optional step. It will prevent the locking of the table because it's usually locked while the removal process of the index. So let's try to drop the above index. We can alter index statement for the purpose of renaming an index specifically in PostgreSQL. The general syntax for renaming an index is this. And in this command, if exist statement, if used, there would be no error raised by alter index statement. And index name, it is necessary because it is the name of the index that we want to change and rename it. And the new index name, it is also important to be specified and correctly entered because it is the new index name that we want to allocate to the index that we want to rename. Alright, now let's try that as well. Now I have dropped the index. Let me create an index again, and so we can rename it. Alright, index is altered. Alright, now let's see how can we use Coalesce operation in PostgreSQL. Let me clear the terminal first. The PostgreSQL Coalesce function is observed to be working as similar to the if null function. Basically, this function is one of the PostgreSQL built-in function. This function is used to evaluate arguments and values from left to right and look for the initial non-null value. Once it finds the first value, it doesn't evaluate the remaining values and arguments. In PostgreSQL, Coalesce function can accept multiple values at a time. All these values are successfully added and accepted. But as a result, this function will only returns first of all the values and arguments, which is not a null value. If in case all the arguments entered are null, then the function as a result will come up with a null value or an empty result in the result set. The general syntax of Coalesce function is this. The select parameter, it fetches data with the help of a Coalesce function. We have an option to use single or multiple columns at once to fetch and store data from a table in PostgreSQL. And the value parameter, it is basically any value used in PostgreSQL with Coalesce function. In the case of multiple values, this function has to return the very first non-null value in the outcome. And the Coalesce, this refers to the specific function name, which results in a first non-null value in PostgreSQL. Not to forget that Coalesce function is of much more significance and found very useful in PostgreSQL. And from parameter, It is actually a keyword which is used in a select query with a table name specifically in PostgreSQL, and description in case if the Coalesce function, the description includes the column name of the table in PostgreSQL specifically for the Coalesce function, and table name attribute, it is used to PostgreSQL with the function being Coalesce, and argument from 1 to n, it is an integer value in PostgreSQL which is passed with Coalesce function by passing 3 arguments at a time. If the first value has null value, only then the respective function will give the second value as an outcome. And column from 1 to n, it is basically a column name in a table in PostgreSQL. For getting multiple data, we must pass multiple columns using Coalesce function at one time. And none is actually an argument passed in PostgreSQL with Coalesce function. And lastly, short description, it is another parameter used while performing the Coalesce function. Let's see how does Coalesce function work. We can replace any default value in PostgreSQL into null values with the help of Coalesce function. It returns the first value if it is not null already in the table. The significance of Coalesce function lies in its function, as it is much useful in PostgreSQL for the action as to return the first value which was not already null in column. We have to assume 0 or other values in PostgreSQL column to find out the actual outcome with the help of Coalesce function. It only results in values or arguments which are not null. So if the value are not null, the Coalesce function will result in null or empty result. Well, Coalesce function are quite similar to if null function in working. Now let's take a look at some examples. In this example, we are considering a discount table for understanding the example. Alright, let's create a discount table first. And now let's insert some data into it. Oops, it's a string. Let me write it down again. Alright, 5 rows are inserted. Now let's see the state of the table with the select command. Alright, Now let's take the first example in which we are using values multiple of 10. So the Coalesce function as a result will only return first values because of the reason that there is no non-null value in the first entered values. Alright? Now in another example, we will pass values including null and other values. Now, because null is present as the first one in the values, thus the result would come up with the second value which is not null. Alright? Now in another example, we are going to add all null values using the Coalesce function. The result will be an empty result because of all the passing values will be null. Alright? Alright, now in another example, we are actually getting back to our actual price of the selected product. And for the discount value, we are using 0 value with the help of Coalesce function. Alright? Alright, that's great. That's it from the Coalesce function. Now let me clear the terminal and let's learn about arrays. So in order to store multiple values in a single database instead of multiple tables, a PostgreSQL is used with array data type. Different data types are present in PostgreSQL. The information of lists can be stored by using the data type known as arrays. Arrays are the most important and useful data type and are seen anywhere in block tags or different book titles. It is not only difficult to combine and join data in tables and rows, but also very expensive. Therefore, arrays are mostly considered because it is easy to use and not so expensive. So now we will actually create a table using arrays, insert data using arrays, indexing arrays, accessing elements of an array, and selection of array elements. Alright, now let's move to our first step, creating a table using arrays. So in order to create a student table, it consists of a name and exam scores that are defined in a multi-dimensional array, and their contact information is defined in a one-dimensional array. Alright, so in this table, brackets notation and arrays keywords will be used to create an array. Let's create a table first with the name of student_test. It's not a test, it's text. Alright. The text data type is used from NME and it includes all the names which have only text character present. The score of the student are an integer array, but to hold several scores, a multi-dimensional array is used and is indicated by double brackets. In case of content details, which contains varchar data type, an array constructor is used. The arrays and brackets constructor are almost similar. Let's take a look at the tables. Alright, student test is created. The PostgreSQL only permits the array to be multidimensional or one-dimensional at a time. If the table is created using double brackets, then it is also possible to insert a one-dimensional array. In the same way, score fields also created as a single-dimensional array using single bracket. and multi-dimensional array with the double brackets. Alright, now after creating a table, the second step is to insert data. Now let's insert data into first. I think I missed a comma in the second or third line. Here. Alright. For each record, there is a unique name for students. The score of the exam are multi-dimensional array. Every array consists of further 4 exam arrays that shows a single exam enclosed within the braces. The value in an array shows the portion of the exam. It is important to have enclosed arrays while inserting a multi-dimensional array. In this way, there isn't a need for students with 3 scores of a single exam, or else an error will occur. Like if I run a query, it throws an error that array expression must be used in multi-dimensional array. Alright? Now let's take a look at indexing arrays. GIN or GIST index is used to index arrays in PostgreSQL. GIST indexes are used for geometric data types, whereas GIN indexes are designed for arrays. PostgreSQL courtesies the GIN index for static data, and if the data is regularly updated, the GIST index is used. Both indexes give the special operator classes for searching the data in arrays. There is no need for special syntax to index the arrays. Index operation is created using the PostgreSQL create index operation, and then the B-tree index is created for student name and GIN indexes for the rest of the column. Let's try some examples. This index was created using GIN. Alright, let's see at B-tree index. Let's create another index using GIN. Alright, let's see how can we access elements of an array. The GIN operator is used to find out the score of the student and the contact detail that match the record of a particular student while accessing the details. Let's try that. In the absence of GIN index, a sequential scan is performed that helps in looking for all the contents in a table before returning the right student. To find out the specific score using a multi-dimensional array is quite tough. Now if I try to search for a score greater than 97, that was my mistake, and here as well. Alright. As it is an expensive way, therefore another approach is used. This is to search through array using an int array extension. This extension is installed by writing when the extension is installed, drop the score using index drop index idx_score. Then create the new index with the help of installed int array extension and using operator class gin_int_obs. Alright? After creating the new index and running the explain query, the rapid results will be shown. So to search the particular score of a single exam instead of all the exam, use this query. Oops, semicolon should be out of the bracket. I made a mistake. Let me write it down again. Alright. Now there is seen an array slice. This only selects the initial array of scores. There occurs an issue because both dimensions of an array are not indexed. Like Alright, for indexing two dimensions, it is essential to set two indexes. Student names ought to be in one column and the exam score of those students must be in another column, just like I'm gonna do in this query. Alright, at this moment set the GIN index on the column of scores and then run the query as student score. Alright, and now to see further performance, run the expression explain. Alright, from all this, it is clear that the PostgreSQL prefers sequential scan than the index as it automatically chooses the fastest method to query the data. Now let's move to our next step, selection of array elements. So in PostgreSQL, values are also searched by using array sub-expression any. Its drawback is that it results in a significant loss for larger dataset as it doesn't use an index. The expression is placed in front of the where clause on the operator's right side, where creating a query using any conditional statement. The any expression provides similar result for students. The explain expression is used to see real performance problem, just like this. Alright, this is how simple is this. But it is important to use an index on a column instead of using any. Alright, this is it from the arrays topic. Let's move to our next topic. Joins. We'll see some ways to use joins, including inner and outer by using visual illustrations, various examples, and by using syntax. The data is retrieved from multiple tables by using joins. When two or more tables are linked in a SQL statement, then a join is performed. These PostgreSQL joins are of different types, which are PostgreSQL with the inner join, also known as simple join, left outer join, are also known as left join, and right outer join, also known as right join, and full outer join, and something called as full join. First, start with inner join as simple join. It is a very common type and return all the rows from the different tables at a place where the condition is met. Let's directly take an example to understand it better. Now in this example, although the tables supplier and orders don't exist, but I am assuming them just for the sake of understanding the syntax and how this join works. Alright, now in this query, the inner join will send back all the rows from the order tables and suppliers at every location with the similar supplier ID value. Alright, it throws an error because tables don't exist. Now the second type of join is left outer join. It is the type of join that returns each of the row from the left-hand table in which the on condition is specified, including the rows in which the condition of the join met. Let's take a look at its example as well. Alright, from the supplier table, the left outer join will return each of the rows, and from the orders, the table returns only those where the join fields are identical. Next is right outer join. It is the third type of join. It returns each of the rows that are specified in the right hand table in on condition and from other tables with just those rows at where the fields are equal. Let's take a look at this example as well. Now from the order table, the right outer join will also return each of the rows, and from the splitter, the table returns only those where the joined fields are identical. Alright, I hope it's very clear. Now the next join is full outer join. In this join, if a condition is not met, then it will return all the not null values in both of the tables. So let's go through its example. Now in this join, from the splitter table, the right outer join will also return each of the rows, and from the other tables where the joined fields are not identical, but the null will be extended as a result. Alright. So now let's move to our next topic, how to use where in arrays. Different columns are defined in a table with variable length as a multi-dimensional array. All these arrays comprised of different types, like it may be any built-in base type, enum or composite type. To filter the array data, the where clause will be used. As it is clear that various columns are defined as arrays, therefore while working with arrays, there is a need to change and query the data in arrays. The main advantage is that the where clause is very easy to use in SQL statements in order to manipulate and access the data of array. Alright, let's do some practical stuff to understand it better. So first create a table in PostgreSQL. Alright, now let's take an example in which the text value of a multi-dimensional array is controlled with the help of column grades. So insert some record into the table. Alright, now let's use where clause in array. Alright, after using this query, it is clear that the name of each record will be returned in which there is a value 1 in case of the second value. Alright, now let's try the where clause in the array to modify the data. So let's see the new values after update. Alright, that's great. So this is it from the where clause. Now let's move to our next topic, how to store and query JSON in PostgreSQL. The JSON is basically a file format that is actually open standardized. This file format is used to arrange key value pairs also with array data types under the action of certain syntactic rules. Majorly, it is adopted as a primary format in web series for transmitting data because of the fact that as compared to the older version of XML, it is much lightweight. Thus, this justifies the most common use and need of JSON to perform all possible kinds of analysis by this format. In order to understand, let's think about the example of a person, object named Pedro and height 1.9. The representation of this object in JSON would look like this. Now, this is a very simple example, but you will see the JSON doesn't go much beyond that. The most important thing you need to know about JSON is that it is composed of key value. The key represents name of the class attributes and the value are the values of the object. So in this example, we have the keys name and height and the values Pedro and 1.90 respectively. The syntax of JSON is quite simple, but now we are going to go a little deeper. Let's look at the basic elements of JSON. Curly braces delimit an object, brackets delimit an array, and colon separates key attributes from values and comma separates the key value attributes. So by understanding these four basic elements, you will be able to read a JSON more easily. The simple reading of a JSON is that it represents an object that has attributes and each attribute has values. JSONs are structured in objects are represented by keys curly braces and arrays are represented by square brackets. Well, there are two distinct data types for holding and storing data. In 2012, PostgreSQL was released with two distinct data types for holding and storing data. One is JSON and the other one is JSONB. The best part is that data formatted in JSONB can also be stored as a plain text, which makes it more preferable to use. According to the rules of JSON, the data and the values stored in such format are valid, and therefore these lead to more utilized of the JSON format types. These formats unlock many other functions and operatives for the practice of storing and manipulating these values. This JSON data type functions in a way that it holds and stores an exact copy of the text added as an input text. Thus, this leads to again and again decoding of the text whenever needed. On the other side, the JSONB works in contrast to JSON. It stores data in the form of a binary format, which decomposes so that there is no parsing required at a large stage. But in the case of JSONB, there are small delays noticed at the time of input because of the conversion into binary format. So overall, considering the application between JSON and JSONB, the most used one is JSONB. But if there are some other specific needs, others are also adopted. Now it's time to try some example and understand more clearly. First, create a database. Now connect to this database. Now create a table. Let's insert some data into it. Alright, now to see the stored JSON data, execute the select static from sales command. Now we will insert a JSON column in a table in order to use it for JSON functions that are necessary for working with JSON document. Alright. Now update the key for the sales table. Update again by removing another key. Now query the JSON document by executing the command. This is performed in order to use all other functions including in JSON. All of these operators that I used are available as additional content for the JSONB columns. And I hope you can't understand what this query is doing, so let's see some of the basic functions. First, containment. While comparing JSON with the JSONB containment test proves to be one of the major differences. So while working with JSON, there is no direct availability of this operation, while on the other hand, JSONB is very handy and has a suitable solution for the containment as the operator for the containment at greater than. For example, an array is whether contained within another set or array or not. The basic concept about at greater than is about the contained object that must be matching the other contained object in the structure and the data contents. While considering the order of set or array elements, the duplicate objects are considered for a single time at the time of conducting a containment check. Another function is basic operator. There are various functions and operators offered by JSON and JSONB data types. Through the help of those functions, we can get various objects like array elements by key, index, or specified object or paths. In PostgreSQL, various operators are available like dash greater than, which is referring to the int, and dash greater than referring to the text. Another function is existence. There are also offered existence operators by JSONB data types, which are considered to be operating just like the idea of containment. We are targeting and discussing about such cases in which we are interested to know if a string appears as an array or like a key of top level in PostgreSQL JSONB object. In such a case, only the top level objects are considered. So for example, the execution of this query that I have written it down, as I said, it comes up with an outcome of being true due to what is eminent to be extant in the respected array. Alright? But let's move toward the next step, query cheat sheet. After discussing JSON in detail, we will now create a cheat sheet that contains example of the queries that are common among the users. Before studying the example, let us suppose the existence of a table in PostgreSQL, which is named as sales, and also comparing of a JSONB column further named products. However, these commands are just example and will return no value as you will need to define these items in the sales table. So from the first level attributes, the product by value is selected. The first option of all involves the containment operator, which is as an alternative, you can also use dash greater than because it is helpful while retrieving with the key for the JSON object field. Further, this key can also be used and is considered valid in the case of column products for type JSON in PostgreSQL instead of JSONB. So let's do this. Alright, now let's see how can we do the selection of products from nested attribute by value. There are basically two options in such a case. The first one is by the containment operator. And the other is using dash greater than. And now let's see how can we do the selection of products from any array attribute by value. Let's suppose an array contains some available size for every product as available size small, medium or large. So one query, it buys entering available size medium. And now selection by choosing the product or item's name. In such case, the operator dash greater than is used directly in the clause name select. In this, in an existing attribute way, we can retrieve the present value. Alright, so this is it from the JSON data type. Now let's move to our next topic. The like condition. Like condition is used to match the pattern with syntax and various examples. It allows anyone to do the pattern matching. It also permits the wildcards to use them in a where clause for the various statements like select, update, insert and delete. First of all, you will have to create a table workers with first name, last name and worker number columns. Alright, so first create a table. All the examples that I'm gonna try will be based on this table. So the syntax is this. In this, expression is defined as character expression like the field or column, and pattern is a character expression having a matching pattern. It has further two types. Wildcard percentage enable us to match a string of any length, and wildcard underscore enable us to match a single character. And escape character in this statement is an optional keyword and enable us to access the literal instance of the wild character. The PostgreSQL automatically assumes a backslash as an escape character when the escape character is not provided. So first see the example of percentage wildcard. The example for the like statement includes the use of percentage wildcard to identify all the workers having their first name starting with Joe. Alright, so let's see. Now this percentage wildcard can also be used several times in a similar string, just like this. Alright, since there was no data inserted, that's why it shows 0 rows. Well, in the percentage, we want to get all those workers with their first name containing the character JO. Now let's see the example of underscore wildcard as well. Now in this, the like condition will return all those spliers having the 5-character long splier's name. But in this case, the first 3 characters will be JAS and the last character will be the N. For example, it will return the worker having their first name JSON, JSON, JSON or JSON. Alright, it might be possible to find if you are searching for an account number with only having 5 or 6 digits. Let's see another example. This example will fetch back some results in which the missing value will be from 0 to 9, like it will return only those workers having worker number from 98760 to 98769. Alright, now we'll see how to use NOT operator with the help of wildcard. First we'll use the percentage wildcard with NOT operator. Alright, now we can also retrieve all the workers having last name with not a J letter by placing the NOT operator in front of like condition. Alright, just like this. Let's see the example of escape characters. It is essential to realize that the escape character used whenever the patterns match each other. Suppose if we wanted to look for the percentage A underscore character in a like condition, then this can only be possible by using the escape character. It should be kept in mind that the escape character can only be defined as a single character having a length of 1. So let's see an example. As the escape character is not specific, therefore the PostgreSQL stores the escape character as backslash. Finally, the statement will return all the workers having last name with G and percentage. The default escape character can override in the PostgreSQL by giving escape modifier, just like this. Now in this example, the like condition helps to identify the exclamation character as the escape character. By using this exclamation escape character, PostgreSQL will treat the 5 character as a literal. The output will also return those workers having the last name with G%. Alright? Now let us see another difficult example that uses the escape character in the PostgreSQL like condition. Now this example of the like condition will return those workers having last names starting with M and finish using percentage. For instance, it will return the value of Matheson percentage. Here the escape character is not specified in the like condition. Therefore, PostgreSQL assume it as backslash. This in return results in taking the second percentage character as literal by PostgreSQL than that of the wildcard. Alright? Now the like condition is modified by describing the escape character. Now this example of like condition return all the workers with the last name starting with the letter M and finishes with the literal percentage. For instance, a value such as Matheson percentage will be returned. The escape character in the like condition can also be used with the A_ character. Let us see that example as well. Let me clear the terminal. Here again we will observe that there is no escape modifier present. Therefore, the PostgreSQL using the backslash as an escape character. This will result in underscore character will be taken as literal than that of the wildcard. Now this example will return those workers having last name starting with the letter M and finishes with the underscore. For instance, a value such as Matheson underscore will be returned. Alright, I hope you understand the like condition very well. Now let's move to our next topic, that is date, timestamp and time zones. In PostgreSQL, implementing the calendar is easy and good. For this purpose, we will see some examples. Time zone is an important tool, but these cannot be solved using an engineering principle. It is quite a complicated task to handle or control the date, time and time zones. It is essential to use the timestamps with the time zones, as there is a very popular myth that says the stored time zone will be added to footprint or the memory. Let's run a query to better understand it. Alright, in the PostgreSQL, there is a default big int data type for the timestamps present and stored inside the system. The formats of on disk and in memory are similar, having or without having the time zone spot. Now let us see how the PostgreSQL works for the timestamp. The stored interval value will always be in Universal Coordinate Time (UTC), which is also called Greenwich Mean Time (GMT). A value with an explicitly defined time zone would be converted to UTC with the help of the offset, which is particularly for the time zone. But if the time zone is not mentioned in an input string, then it is automatically taken as a parameter of the system's time zone. It is then changed to UTC with the offset of time zones. Alright, now I'm gonna write some commands and fast forward them to save the time, and we'll discuss them later. Alright, now in this scenario, it is seen that the time zone setting of the client which is converted from one French value to another French value similar to Tahiti, which is a Pacific island in France. Firstly, it is observed that the same timestamp is returned by the now function in one operation. To see the running clock in the transaction, for this purpose, the clock underscore timestamp function is used. Next, it is observed that after changing the client setting of time zone, then output timestamp by PostgreSQL is similar to the selected time zone. While managing an application with the users and contrasting time zones and wanted to show the time in local time zone, to do this, the time zone should be set in an application code before any processing, and the rest of the work is handled by PostgreSQL. At last, after choosing from the TSTZ table, it is observed that each of the inserted value realized by the column TSTZ are at the same point in time, but they seem different in different places of the word. Thus, it is not possible to compare the entries and to know what exactly happens at a similar time using that TS column. As it was discussed earlier, that the use of timestamp with the time zone, the PostgreSQL at the time of input doesn't store time zone. Therefore, it is not clear that the entries in the table TSTZ are at the same time but from different places. Many other options are present for inputting the timestamp values. The ISO format is simple and easy. This example describes that the left out time zone is controlled by session parameter of time zone. Alright? PostgreSQL prefers to parse the literal values in the DML statement as it knows the targeted column. For the applications with date-only use cases, the data type is used to compare the date and timestamp with time zone is possible in the SQL queries. Alright, now let's see about time intervals. An interval data type is implemented by the PostgreSQL with data type like date, time and timestamp z. An interval is said to be a duration which as weeks or months or a millisecond, various values for the interval style are feasible, and the Postgres_verbose setting for the SQL session is now if I select some interval, now the results seem different as I selected, so this was helpful. The duration of the month depends on which particular month. So let's see that. Let me clear the terminal first and write down the query. Now I will gonna fast forward again because this query is so long. Oops, I made a mistake. I made a syntax error. These brackets shouldn't be here. This one. Alright. Alright, now it throws an error that the table doesn't exist, but our purpose was to understand the syntax. Alright, now after attaching the interval timestamp or date in PostgreSQL, therefore in that case the number of days is adjusted with the specific calendar that is selected, else the interval is assumed to be 30 days, the last day of February is computed. Alright, so this is it from the date, time and timestamp topic. Now let's see our next topic, which is how to execute the PostgreSQL upsert in a table. The specified updates will occur only in the existence of records that fulfill the criteria of the query, and when there is no record, then there will be no steps are taken. When the record is not found in the existing record and wants to insert a new record, then use the upsert SQL combining update and insert that will do the merge operation. A record that is not present will be added or updated by the Postgres. So in order to understand this, we have to first create a database and table and then just do the insertion and updation thing. Alright, so first create a database. Now connect to the database. Now create a table. Oops, I made a mistake again. Let me write it down again. Alright, student table already exists. Let's change the name to student from student 1 or 2, let's say. Alright, as it has been discussed earlier that upsert is created after combining the two SQL commands, it will permit to insert into a table if no match is available in record and also allow to update an existing record. Now here we will see how to insert some record into a table named student 1. Here we'll also use a select query which in turn return and show the values of some table. Alright, the onConflict clause is also used in conjunction along with the insert command. Let's see that as well. Now note that by using the onConflict keyword in this example, It will not let the PostgreSQL alter the keywords inside the table while conflicting or duplicating the date. Therefore, nothing has been changed upon using insert. And another thing, in an on conflict, the word conflict means the restriction to throw the error upon inserting the same values. These errors are avoided by do nothing or not changing the pre-existed rows. Alright, so to verify whether this operation is successful or not, this can be done by performing the select statement for the record having ID 1516. Alright, now let's see an example of Postgres UPSERT as well. Let me clear the terminal. Now in this example, let us assume a situation in which there is a need to change a value inside a column. For instance, in the above example that we discussed, the email field from a value john.doe@xyz.com is changed to the new value that is john.doe@abc.com. Alright, so let's try to do that. Now let's run the select statement to see the results. Finally, it is observed that the excluded keyword identifies the update value instead of inserted value in the table. Alright, now let's talk about triggers. Triggers are one of the basic and main attributes that incorporate the unchangeable system of SQL servers, including the PostgreSQL server. All these include diverse scenarios from the simple one like log in audit to the tough and advanced tasks like updating the remote database that are very practical or beneficial. When certain conditions or a specified event are fulfilled by the users, then the function is executed, which is known as trigger. The various actions that are performed inside a trigger may include several things starting from adding, updating, deleting the data and data rows from the database. Naturally, the triggers are bounded with database tables and are generated at the time of table creation. In other words, it is utilized in a way the if condition is utilized in C or C++ to check whether the set condition is supposed to be true or false. This is the only way to execute the inside instructions of the condition. So how can we use the triggers? Here we take an example in which we assume a table of workers having the detail of worker and pay. In this example, we see that triggers help automate the unnecessary tasks like that updating the audit log upon updating the employee or pay detail inside the table. Triggers are applied to automate the task that is of huge benefit when frequently the update occurs. Therefore, the audit logging is done instantly, restricting the tampering opportunity. Here in this case, also the logging table is manually updated and residing it before or after the values may lead the harmful manipulation and input error. Let's see an example of insert and update triggers. The trigger is launched when the insert and update take place in table. They work as the name suggests, insert and update triggers. In the next example that we are going to do, two tables are created that are workers and log underscore trigger. After the creation of the table, the two triggers are created to update the table of the logs underscore trigger when an entry is added to the workers table. Similar will be the result when the pay detail are updated. In the first step, create a table of workers and log underscore trigger like this. Let me connect to the Postgres database again. The table workers already exist. Let me change the name of the table. Workers1 will be the fine, I think. Alright, let's create the table logs underscore trigger. You can check for both of these tables by typing the command \tt. Alright, now let me clear the terminal. Now we'll see the way to create the logging function. So let's do it. Alright, now we have to create two triggers for workers and pay. The first one creates the trail of the audit when the insert is performed inside the workers table, and the second upon updating the data. Alright, so first create the first trigger. Now the second trigger. Oops, I made a mistake because my table's name was not workers, it was workers1. Alright. That should work. Great. Now in the next step, well, actually I need to change my first trigger as well. So let me change that again. Alright, now we'll insert some data in the workers table. Well, actually I made a mistake again. Insert into workers1. It should be. Alright. So workers1. Oops, it's a string. Let me change that. Alright, now let's check the workers table. Alright, the data is inserted perfectly. Now to view the data inside the table of logs trigger, run this command. You will observe that concerning entry is added to the table as well. Now the record of John is updated and the pay status is set from pending to paid with the help of update statement, just like this. Alright, this is how simple is that. Now let's verify it. Oops, I made a mistake, it was a static. Alright, it is updated. Now if I check the logs trigger, it is updated as well. That's great. Alright, now let me clear the terminal and let's see some examples of instead of triggers. This trigger is applied for the insert, update and delete statements. These are known as instead of triggers due to database that performs the trigger statement instead of. Now initially we'll create a plain and simple view having the 11 workers with the ID from 1 to 11 in which John is a member. Now if I select static from 11 workers, this table will be shown. Now we will generate a function that prohibits updating the worker's pay. Alright, now the instead of trigger is used for updating the pay of the worker, which is associated with the 11 workers table. Now let's try to update the pay. Now select static from workers. As we can see that the trigger prevented the page change. That's great, we have done it. Alright, so this is it from the triggers topic, but there are some types of triggers that are not currently supported, but these can be tracked using the GitHub issues. These include the event triggers, deferrable constraints, referencing clause for triggers. Alright, so this was the last topic of this long course, and I hope this long course helps you in learning and understanding the PostgreSQL and its fundamentals. So if you want more courses like this, so don't forget to subscribe this channel and like this video. Thank you so much.